Hello everyone, welcome to day 2 of MPLS series. Guys, this is day 2 of MPLS. In day 1 we had discussed why we come up with MPLS, where we need to use it, right? We had discussed some scenario where we need to use MPLS. Without MPLS, we need to purchase good hardware routers in ISP network, in SP network. So that's why we come up with MPLS. And yesterday I told you that MPLS router will forward traffic on the basis of label, and today we are going to understand how routers are going to assign label to prefixes, guys. Before starting the session, one thing that you need to keep in mind is all the MPLS enabled routers, what I am saying, all routers where you have enabled the MPLS will assign one label to all the prefixes which is present in routing table. Means routers will assign one label to all the prefixes present in routing table, and that is called local label. Like, see, in this scenario I have 4 router, router 1, router 2, router 3 and router 4. Router 1 have one LAN network, that is 10.1.1.0/24. Router 4 have also one LAN, that is 40.1.1.0/24. First of all, we will configure IGP protocol. IGP means any interior gateway routing protocol. That can be RIP, that can be AGRP, that can be OSPF. So let's say I have configured OSPF on all routers. Soon in upcoming day you will understand why we need to configure IGP protocol here also, guys. Because to form LDP neighbor, let's say router 1 have one loopback and router 2 have one loopback. Router 1 have one loopback where IP address is 1.1.1.1 and router 2 have one loopback 2.2.2, and you want to form LDP neighborship. Now if you are thinking what is LDP, so guys, LDP is a protocol. What is routing protocol? What is OSPF? OSPF routing protocol is used to exchange routing information between routers, and LDP is a protocol which is used to exchange label between routers. Okay, so first LDP will form neighborship and then it is going to exchange label. So this is LDP is a separate topic. We will understand LDP protocols in detail. Don't worry about the LDP. Okay, and in upcoming day you will understand this also, that why we need to configure IGP protocol between router 1 to router 4 first. Then only you will configure MPLS. MPLS is what? MPLS is label based forwarding. So router 1 will assign label, local label, to those prefixes which are available in their routing table only. Okay, so now you can see this is routing table of router 1. Let's suppose I am running any IGP protocol on all routers. So that's why router 1 have LAN 40 network, 34 network, 23 network in their routing table, and there are 2 directly connected network, that is 10 and 12. So router 1 have total number of 5 number of networks in their routing table. You can see 10.1.1.0, 12.1.1.0, 23.1.1.0 and 34.1.1.0 and 40.1.1.0. In the same way, routing table of all routers is look like similar, right? Because in the routing table of all routers these prefixes will be there, same prefixes will be there. We are not discussing what will be the metric for it. This is a directly connected network. Just I am telling you that router have installed these prefixes in their routing table, and as I told you that MPLS enabled routers will assign one local label to every prefixes present in routing table. So router 1 is going to assign one local label number to all prefixes. Router 2 is also going to assign one local label to all prefixes. Router 3 will also assign one local label to all prefixes, and router 4 will also assign one local label to all prefixes, right? What is the use of this local label? We will discuss these things in upcoming day. Don't worry, just try to understand how routers assign label only in this video. Okay, so these are the routing table. With the help of routing table, router are going to design LIB table. As I told you that whenever you will enable MPLS on router, that router will start maintaining 2 mode table. One is LIB table and another one is LFIB table. LIB table is a part of control plane and LFIB table is a part of data plane. So now actually we are going to understand how these routers will build their LIB table, right? That is a part of control plane. So see, by default router will start assigning label number from 16, because you know what is label? Label is just a value. Label is just a value represented in decimal. It is a 20 bits value. So size of label is 20 bits. So if I will talk about the range, so range can be what? Range can be 0 to 2 to the power 20. This can be the range of label. From this range, router can use any label. But 0 to 15 are reserved. 0 to 15 are reserved. That means router can use label from 16. And guys, for the teaching purpose only, I am going to define a specific range of label on every router. Means I am going to tell to router, please use label number from, let's say, 20 to 30. I am going to tell to router 2, please use label number from, let's say, 100 to 200. I am going to tell to router 3, please use label from this range, from that range. Okay, so we can define that also. But when I will perform practical, then I will show you what default label number routers will assign. Same topology I will design in GNS3 in EVNG, and I will show you practically as well. Don't worry about that, guys. Okay, so for now what I am going to do, I am going to define a specific range of label on every router, just to make you understand, right, how label works and how routers are going to use the label in MPLS. Okay, this is just for teaching purpose. Otherwise, you know, two routers can use same label number as well. Like router 1 have used label number 16 for 10.1.1.0/24 network, and router 2 can also use same label number, that is 16 for 10.1.1.0 network also. Okay, so router can use same label number also and different label number also. But if it will use same label number, then maybe it will be difficult for you to understand how exactly label works. So that's why I am going to define a specific range on all routers. So let's begin from router number 1, guys. Okay, on router number 1, let's say I am going to define the range. I am going to tell to router 1, please use label number from 20 to 30, because we have only 5 prefixes in the routing table, so I have defined only 10 number of label. I am going to tell to router 3, please use label from 31 to 40. Okay, I am going to tell to router 3, please use label number from 41 to, let's say, 50. And I am going to tell to router 4 is use label from 51 to 60 range, from this range. Now if you will define the range on a particular router, then router will use label number from that range only. Okay, so just for the teaching purpose, just to make you understand, I have defined the label number. Later on I will make you understand the default behavior as well. As I told you that router will start using label number from 16, so definitely router 1 will assign label number 16 to 10.1.1.0/24. It will assign 17 to 12, 23 to 18, like this. Here let's say router 1 have assigned label number, that is local label. As I told you, local label, there are two types of label, local label and remote label. Both we are going to discuss in this video. Let's say router 1 have assigned label number from this range. Label for 10.1.1.0/24 network is, it have assigned 20. For 12 network it have assigned 21. For 23 network it have assigned 22. And for 34 network it have assigned 23. And for 40 network it have assigned, let's say, 24. Okay, this is local label number for all prefixes. So as I told you that all MPLS enabled routers will assign a label to all the prefixes which is available in, which is present in routing table. So like this, router have assigned label number to all prefixes. Now router 2 is also going to assign their local label number for all prefixes from this range. So let's say it have assigned label number 31 to 10.1.1.0, 12, 32 to, it have assigned 33 to 23.1.1.0, it have assigned 34 to 34.1.1.0, and 35 to 40.1.1.0. In the same way, router 3 will also assign one local label number. Let's say it have assigned 40, it should use range 41, not 40. So it have assigned, let's say 41, 42, 43, 44 and 45. See, 41 is the label for 10.1.1.0/24 network on router number 3, and this is local label. Okay, for these, for all prefixes it have assigned one local label number. In the same way, router 4 is also going to assign one local label number. It will start from 51. So let's say 51 is for 10 network, for 12 network it have assigned 52, for 23 network it have assigned 53, for 34 network it have assigned, let's say 54, and for 40 network it have assigned 55. Okay, done. It is very easy. All router have assigned one local label number to their prefixes present in routing table. Now the second thing is, with the help of protocol, with the like routing protocols exchange routing information. So routers need to exchange their label. Router 2 will share their own label to router 1, and router 1 will share their own label to router 2. So routers are going to exchange their label with their LDP neighbor. Actually, we have two types of protocol, guys, to exchange label. First one is TDP. Tag distribution protocol. This is Cisco proprietary protocol. We will understand this protocol in upcoming day. Okay, this is TDP, Cisco proprietary protocol, and other one is LDP. TDP stands for tag distribution protocol, and LDP stands for level distribution protocol. And level distribution protocol is an open standard protocol. And nowadays Cisco also using LDP protocol. Getting my point? So there are some benefits definitely of LDP over TDP. That's why we are using LDP protocol. And LDP will form neighborship. There will be one LDP neighborship. Router 1 will have one LDP neighbor, that is router 2. Router 2 have two number of LDP neighbor, router 3 and router 1. Router 3 will also have two number of LDP neighbor. One is router 2 and router 4. Getting my point? Router 1 have one LDP neighbor, that is router 2. Router 2 have two LDP neighbor. So it will receive two number of remote label. Remote label means the label which I have received from neighbor. Okay, first of all, let's start talking about router number 1. From router number 1, when router 2 will share label number to router 1, it will become remote label. It is receiving remote label from which neighbor? From router number 2. And what label it will receive from their neighbor? And that is remote label 31 for 10 prefixes. It is the local label number of router number 2. So it is sharing local label number with router number 1, with their neighbor. So it is receiving 31 for 10 prefixes, 32 for 12 prefixes, 33 for 23 prefixes, and 34 for 34 prefixes, and 35 for 40 prefixes. Getting my point? So these are the remote label. These are the remote label of router number 1. Guys, in real time and when I will configure, I will make you understand there are some difference as well, right? Routers will not assign label number for directly connected network. Okay, that will be implicit deny. So we will understand those things, right? Those are a small concept. First, try to understand the actual concept of labeling. Okay, so router 1 have received the label number from router 2 for all the prefixes. Getting my point? In the same way, this router will receive label, remote label from their two neighbor, from router 1 also and from router number 2 also. So it will receive label from router 1 also. And what label it will receive from their neighbor 1, means from their router 1, it will receive 20 for 10 prefixes, 21 for 12 prefixes, 22 for 23 prefixes, and 23 for 34 prefixes, and 24 for 40 prefixes. So okay, it is going to mention the label over here that I am receiving from my neighbor. Which neighbor? From my neighbor router number 2. 20. Let me change the pin. 20. After that, 21 for 12 network, 22 for 23 network, 23 for 34 network, and 25 for, it have received 20, 21, 22, 23 and 24. 24 for 40 network. Done. After that it will receive one more level from their neighbor, that is R3 is also their neighbor, so it is receiving remote level from this neighbor also, and this neighbor is advertising what level? 41 for 10 prefixes, 42 for 12 prefixes, 43 for 23 prefixes, 44 for 34 prefixes, and 45 for 40 prefixes. Okay, in the same way router 3 have also two neighbor, so it will receive label from two neighbor. Okay, so it is receiving from router 2, let's say first. So what label router 2 is advertising to router 3 for 10 prefixes, local label on router number 2 is, you can see 31, so it will advertise local label number to their neighbor 31, 31 for 10 prefixes, 32 for 12 prefixes, 33 for 23 prefixes, 34 for 34 prefixes, and 35 for 40 prefixes. When router 4 will advertise the label, see here, router 4 is also LDP neighbor, so it will advertise what? 51 for 10 prefixes, 52 for 12 prefixes, 53 for 23 prefixes, 54 for 34 prefixes, and 55 for 40 prefixes. After that router 4 have only one neighbor, router 4 have only one LDP neighbor, that is router number 3, and router 3 is advertising 41 for 10, 42 for 12, 43 for 23, 44 for 34, and 45 for 40. So it is receiving remote label from router number 3, and label is 41 for 10 prefix, 42 for 12 prefix, 43 for 23 prefix, 44 for 34 prefix, and 45 for 40 prefixes. So now you can see all routers have local label number as well as remote label, and you know this table is nothing but LIB table. These are LIB. This is LIB, label information base of R1, LIB table of R1, LIB table of R2, LIB table of R3, and LIB table of R4. This is only the LIB table. Now with the help of LIB table, routers are going to form LFIB table. See how. And guys, it should be very clear to you that router have exchanged their label with the help of a protocol called LDP. For now, just understand this only, that LDP is a protocol which is used to exchange label. Done. After that, see how it is going to design their LFIB table. Let's say this is LFIB table of router 1, this is LFIB table of router 2, this is LFIB table of router 3, and this is LFIB table of router 4. Okay, so in LFIB table, LFIB, what we call in short LFIB, this is a part of data plane. This is a part of control plane. This table is a part of control plane, and these table are part of data plane. So whenever MPLS enable router, or whenever router will receive a labeled packet, it is going to check LFIB table only. Okay, like if I will talk about, if routers will receive unlabeled packet, if router is receiving a normal IP packet, router check which table? Router check routing table like FIB table. In the FIB table it will find next hop IP address and exit interface. After that it will process the packet. But whenever router will receive a labeled packet, then router will not look up their FIB table. Routers are going to look up this table, LFIB table, labeled forward information base. And in LFIB table, router are not going to store their directly connected network. We will understand these things also in detail. Okay, just I am giving you one overview. Like router 1 will not install their directly connected network in their LFIV table. So directly connected network means 10 network and 12 network. It will install 23 network, 23.1.1.0/24. After that, it will install 34 network, 34.1.1.0/24. After that, it will install 40 network, 40.1.1.0/24. Now, what is the local number for 23 network? What is the local number for 23 network? Local number for 23 network is 20. And what is the remote label for this network? That is 31. Getting my point? It will install these two information, only label, because router need label information to forward traffic in MPLS. Okay. After that, what is the local label for 34 network? For 34 network, local label is 23. So, okay, 23. And what is the remote label? 34. For 40 network, what is the local level? 24. And what is the remote level? 35. That's it. After that, this router. See, 10 network is not directly connected, but 12 network is directly connected and 23 is directly connected to router number 2. So it is going to install 10.1.1.0/24 network in L5 table. After that, it is going to install node 12, node 23, 34.1.1.0/24 network, and then 40.1.1.0/24 network. Okay. After that, what is the local number for 10 network? Local level for 10 network is 31. Local level for 34 network is 34, and local level for 40 network is 35. And what is the remote level? This time, see, there are two remote level for 10 network, 34 network, and 40 network. There are two level. So now, as I told you yesterday, that MPLS is dependable on SAF. So if SAF is disabled, then MPLS will not work. Okay. So now you can see router 2 have two remote label. It is going to check their SAF table. It is going to check their SAF table, FIB table, forwarding information base table. In FIB table, guys, if I will talk about router 1 FIB table, so let's say this is FIB table of router 1, and in FIB table there will be 10 network, there will be 40 network, 34 network, right? All network will be there. Just talk about 10 network. 10.1.1.0/24 network will be there in the FIB table. Okay. After that, what will be the next hop for this network? 12.1.1.1. And what will be the exit interface? Exit interface will be, let's say this is, let me assign it exit interface. This is, let's say, 0/0, this is 0/0, this is 0/1, this is 0/0, this is 0/1, this is 0/0, and this is 0/1. Getting my point? Okay. So exit interface will be 0/0 for 10 network. Okay. Exit interface is 0/0. Now, to build LFIB table, router need FIB table, SAF table, FIB table. This is FIB table. In FIB table, they will look for 10 network, what is the next hop IP address and through which neighbor. Actually, I have two neighbor, two LDP neighbor, router 2 and router 3. But in FIB, 10 network is reachable via which neighbor? Via router number 2 or via router number 3. So 10 network is reachable from router number 2 via router number 1, right? 10 network, for 10 network exit interface will be this one, 0/0. Getting my point? So router 2 have two remote label, one from router number 1, one from router number 3, and in FIB table it will check FIB table. In FIB table, FIB table, it will came to know that 10 network is reachable via router number 1. So it will use remote label of router 1. Remote label, what remote label it will use? The remote label which router 1 is advertising to router 2. So router 1 is advertising what remote label? 20. So it will use remote label 20 here only, not 41. Getting my point? After that, for 34 network, it will check FIB table. In FIB table, 34 network is here. 34 network will be reachable via router number 3. So it will use label number which router 3 is advertising to router 2. So for 34 network, for 34 network. Here is 34 network. What is the label R3 is advertising? 44. So it will use remote label 44 only. Okay. After that, for 40 network, again 40 network is here. 40 network is reachable in SAP via router number 3. So it will use label number of router 3. So router 3 is advertising 45 label number. So here it will use 45. Getting my point? It's very easy. Yes or no? After that, router 3. Router 3 will also not install their directly connected network like 23 and 34 in the LFIB table. So in LFIB table there will be 10 network, 10.1.1.0/24. After that 12 network will be there, 12.1.1.0/24. Then 40 network will be there, 40.1.1.0/24. What is the local number for 10 prefixes? Local number for 10 prefixes is 41. Local level for 12 network is 42 and local level for 40 network is 45. What is the remote level? So two neighbor are advertising remote level, right? Okay, so for 10 network it will check SAP table. In SAP table, best route is exit interface will be this one, F0/0 on router number 3. So means via router number 3 in SAP table it will see 10 network is reachable via router number 2, right? So it will use label number of router 2, that is 31. After that 12 network, for 12 network also it will use via router number 2 because 12 network is here. 12 network from router number 3, 12 network is reachable via router number 2. So what label router 2 is advertising to router 3, that label will become remote label for 12 network. Getting my point what I am saying? Okay, so for 12 network also it will check what label number router 2 is advertising, 32. So it will install 32. After that, for 40 network it will check what SAP table. In SAP table 40 network is reachable via which router? Via router number 4 because 40 network is here, you can see. So it will use what level? Who is router 4 is advertising. Router 4 is advertising what level? 55. So it will add 55 over here. Okay, so in you can see LFIB table there are only local level and one remote level, right? Okay. After that, if I will talk about LFIB table of router number 4, so router 4 will not have 40 network and 34 network. There will be 10 network, 10.1.1.0/24. After that 12.1.1.0/24. After that 23.1.1.0/24. What is the local level for 10 network? Local level is 51. Local level for 12 network is 52. Local level for 23 network is 53. Remote level, only one neighbor is advertising. So these will be, now router 4 don't have compare because only one neighbor is advertising remote label. So for 10 network, what remote label is I am getting from my neighbor? 41. So it will use 41 here. For 12 network 42. For 23 network, wait, this is for 10 network 41. For 12 network it is 42 and for 23 network it is 43. These are the LFIB table of all routers. First router have built this table, LIB table. With the help of LIB and SAP, it have designed LFIB table. And now whenever MPLS router need to forward any packet, it is going to check this table only. This is a part of data plane. This is a part of control plane. Now let's say here is one user. Whose IP address is 10.1.1.1 and here is one user whose IP address is, let's say, 40.1.1.1. Now if 10.1.1.1 want to communicate with 40.1.1.1, see guys, on all routers we have enabled MPLS, but this PC will generate unlabeled traffic. It will generate ICMP traffic. In ICMP traffic, source will be what? 10.1 and destination will be what? 40.1. This PC will forward traffic to router. Router will receive this traffic on this particular interface. Getting my point? It will check what? Destination. At layer 2 first it will check layer 2 information. At layer 2 source MAC will be, let's say, 0A and destination MAC will be the MAC address of default gateway, let's say 0B. Okay, so it have checked the destination MAC. So okay, destination MAC have matched. Then router have came to know that okay, this is a packet for me only. Let me check the destination. Destination is what, 40.1.1.1. Now this is unlabeled traffic. Router will check which table? Router will check FIB table. In the FIB table also there will be one label number. Now if I will talk about the FIB table of router 1. So in FIB table, guys, for 40 network, 40.1.1.0/24 network, exit interface will be, see, on all routers here there will be exit interface as well in LFIB table. Like for 23 network, 23 network is here, so exit interface will be 0/0. 34 network 0/0 will be the exit interface. 40 network 0/0 will be the exit interface. On router number 2, 10 network is reachable via 0/0 as well, and it will mention exit interface as well in LFIB table. Okay, after that for 34 network exit interface will be 0/1, and for 40 network exit interface will be 0/1. In the same way, router 3 for 10 network exit interface will be 0/0. For 12 network exit interface will be again 0/0, but 40 network exit interface will be 0/1. For 10 network 0/0, for 34 network, for 12 network 0/0, and for 23 network 0/0. Okay, so there will be exit interface as well. Now in FIB table there will be one prefix 40.1.1.0. I am talking about the R1, reachable via which router? 12.1.1.2, and next hop is 0/0. This is the information right before enable MPLS, but when you will enable MPLS, it will add one label, one new things will appear in FIB table, that is label. There will be information of label. Install remote label, that is 31. Okay, so when router will look up their FIB table, router 1 will came to know that okay, for this network there is one level, that is 31. So it will add MPLS header. You know, earlier packet was like this: source IP 10.1, destination IP 40.1, source MAC 0A, destination MAC 0B. Now router 1 is going to add MPLS header between layer 2 and layer 3. Source will be 10.1.1.1, destination will be 40.1.1.1, and it is going to add MPLS header over here. In MPLS header it will add what? Label. What label? Remote label. What is the remote label for 40 network? 35. And then layer 2 header, let's say Ethernet. Okay, after that it will forward, router 1 will forward to router 2. When router 2 will receive it, first it will check layer 2 information. After that it is going to check what? MPLS header. In MPLS header, label is 35, and 35 is the local label. You can see here, local level, 35 is local level for 40 network. Okay, local level is used to receive the traffic. Getting my point? Okay, don't worry if you are not getting, I will make you understand these things in upcoming video. Local level is used to receive the traffic, and remote level is used to forward the traffic. Okay, so it have received the traffic where destination is 40.1.1.1. Router 2 is not going to check IP header. Router 2 is not going to check IP header. It will check what? MPLS header. It will came to know that okay, local level is 35 and remote level for 40 network is 45. It will swap the level. It will what? Swap the level from 35 to 45. It will, source will be same 10.1, destination will be same 40.1, and in MPLS level it will swap the level. MPLS level will become 45, and after that it will forward to router 3. When router 3 will receive it, it will check what? MPLS level. 45 is the local level for 40 network. As I am telling you that local level is used to receive the traffic. 45 is the level for 40.1.1.1. It will check remotely as remote level. Remote level is 55. Again it is going to swap the label. Source IP will be same 10.1, 40.1. It is not going to check layer 3 information. After that in MPLS header it will swap the level, that is 55. And it will forward to router number 4. Router 4 will also receive labeled packet. First of all it will check what? Label number. Okay, then it is going to check what? LFIB table, this table. In this table you can see there is no any label for 40.1.1.0 network. There is no any label for 40.1.1.0 router. So router 4 will remove the label. Router 4 will remove the MPLS header, and then router 4 is going to check their FIB table. So here router 4 have to check two table. One is LFIB table first, because it is receiving labeled packet, and second it will check FIB table, right? Because there is no any label in LFIB table. So whenever, as you know, routers check more than one table to forward a packet, that is recursive lookup. This is not good, and we will resolve it with the help of PHP. In upcoming day we will understand this concept also. PHP, penultimate hop popping. So penultimate hop popping means penultimate hop popping. Popping means removing the label. So router 4 is now removing the label. So before one hop, penultimate means what, you guys? Before the last. So before the last router is router number 4. Before the last router 3 will remove the MPLS header, so that router 4 should not check two number of table. So we will understand that concept. This is not our today concept, okay? Today just you need to understand one more thing. Now router 1 is adding the label, and router 4 is removing the label, and router 2 and router 3 is swapping the label. Getting my point? Router 1 is adding the label, router 4 is removing the label, and router 2 and router 3 is swapping the label. So the router who add the MPLS label, that type of router is called ingress LSR. Ingress LSR. All MPLS enabled router is called LSR router, and the router who will add the MPLS header, that type of router is known as ingress LSR, and the router who remove the MPLS header, that type of router is called egress LSR. LSR stands for label switch router. Label switch router. So router 4 is my egress LSR, router 1 is my ingress LSR, and these two routers are, who is swapping the label, are called intermediate router, are called, or you can say normal LSR. These are LSR router. Getting my point? And whenever router add the MPLS header or label, that is called pushing. Push the label. When router swap the label, replace the label, whenever router will replace the label, that is called swapping. These are the term in MPLS I am going to use. That's why I am telling you. Swapping means replace the label, and popping means remove the label. Popping means remove the label. So there are three operations of label. One, adding the label, pushing the label. Second, swapping the label, and third, popping the label. Okay, label, how we will add the label? One router will add the label, and one router will remove the label, and some router will swap the label. Okay, so like in this scenario. And here we can to R1, to this type of router, we can call R1 to edge LSR as well. This type of router is called edge LSR. Router 1 and router 4 is also edge LSR, and these are normal LSR. Okay, so guys, today we had just understand how routers label to the prefixes. In upcoming video, we will understand these things in detail. We will understand the configuration part as well, right? Now we need to understand practically the difference between FIB table, LIB table, right? How labels router are going to use, what is the command to define these range of label. So in upcoming day or in next video, we will show you through my computer screen. Okay guys, so that's all for today. If you have liked this video, if you have learned something from this video, please hit on like button. If you have not subscribed the channel, please subscribe the channel. We will meet soon in next video. Till then, stay safe guys. Bye bye.